organization was allocated with 256 addresses, and out of 256 addresses, 128. So it has three organizations, and three organizations. It has allocated. They requested for 120 M2 connection. Another organization requested for what I mean to say 60 connection, and another organization requested for 10 connections. But since these, 120 connections was not a power of 2, so this has to be made to be a power of 2. So we had taken it as what I'm say 128, which is power of 2, 64, which is power of 2, 16 again is a power of 2. So this is how we have divided, and we had already calculated the prefix size in each case. Prefix size in each case. So in first case, the prefix size was what I would say 25, and second case prefix size was 26. In third case, the prefix size was 28. Yesterday we had calculated, and we had also calculated the beginning address and the end address, last address in each case. And we had also shown that 48 connections were unused. 48 connections were unused. Now we will go for what I meant to say aggregation of what I meant to say the addresses. So it is also called as basically advantage of Cedar strategy, right? So it is called address summarization or route summarization. Now in this case, what happens, when block addresses are combined to create a larger address, routing can be done based on prefix of the larger box block. This is what has been done. So now we will see, small block addresses can be, assigned to 4 organizations. So here ISP combines 4 blocks into one single block. Now we have seen one block was divided into 4 sub blocks. Now here 4 sub blocks are being combined into a single block kind of thing. So for the network, so this is what has been done. So it is something that all packages coming from outside the country, it is something like this. Suppose from USA a package has come to India, so it will come to Delhi first, and from Delhi it is distributed across the country kind of thing. So only one address. So small addresses will be aggregated into a single big address, and this big address, larger block is sent to the internet service provider. So this is what happens. So here you can see in this figure, I have block 1. Which is address is starting from 160 what I'm say .70.14.0, and it goes up to 63. That means 64 connections are here, and block size is the prefix size is 26. Here from 64 to 127. So this is nothing but again 64 what I meant to say connections are there, and here 128 to 191, right? And then from 192 to 255. So total 255, 0 to 255 connections. That means 256 connections are there. And the moment any packet is generated from any of these blocks, that will be aggregated over here, and that all the packets with destination address this from 160 .70 .14.0 to 160.20.14 to 255. Single packet, it will be a larger block will be formed, and with single address it will go to the internet. This is what happens. Single this thing. Now basically special addresses that are associated with IPv4. So IPv4 has 5 types of special addresses. One is called this host address. Second is called limited broadcast address. Third is called loopback address. Right? Third is called loopback address, and fourth is called private address, and fifth is called multicast address. Now we shall see them one by one. So this host address, basically, it will have this address only. You got the idea? So that is 0000, and the whole, what I meant to say, this thing 32 it is. That means here the entire this thing is covered. What is 32 here? What is 32 here?
Prefix.
It is prefix. That means this host address will always be 0000. Right, and 32 prefix is entire 32s. That means there is no chance for any other sub networking and all. So this is called this host address. So basically it is used whenever host wants to send an IP datagram, but it does not know its own address. You got the idea? Suppose I'm a machine. I do not know my, what I meant to say, own address, IP address. In that case, I'll be sending this. This host address is 000 because I do not know what is my host address. So it is the network which will give me that IP address. So this host address as such, it gives this thing. Right now, there is something called as limited broadcast address. Limited broadcast address is all 255s, 255, 255, 255, 255. And here again, the prefix is 32. It is called limited broadcast address. That means, whenever a router or a host wants to send datagram to all the devices that are connected to the network. You got the idea? So it will send this particular address, that 255.255.255.255/32. Moment any device that is connected to the network will be getting the packet, that datagram sent by the host will be getting that particular this thing. So this is called limited broadcast. Now in the router, this particular packet will not have any destination address, so it will not be forwarded by the router. Whenever a packet comes to router, its job is to see the destination address and forward the packet to next router or destination. This is what a router does. But whenever a broadcast message comes with IP address 255.255.255.255, right, it will not send that packet to anywhere because it does not have a destination. It is meant for that packet, whichever is having this IP address is meant for every host. So after receiving, every router will not pass it to the network. It will not send it outside the network. That is there. Now another what I meant to say, address, special type of address is called loopback address, which is nothing but 127.0.0.0 and 8. So prefix is of the size 8. And if the packet is having this particular address, you got the idea? In that case, this packet will never leave the host. It will remain inside the host. That means this packet, whichever packet means block, whichever is there, and it is having loopback address. Loopback address means here both the source and destination will be the same. It will not leave the source itself. You got the idea? Generally it is used for testing the software, piece of software in the machine. So machine sends a test packet and receives it to check whether the software is working properly or not. Right? So this is called loopback address. That means the packet remains. So source and destination both are the host itself. Sending host and receiving host are the host itself. And why this particular packet loopback address is used? This packet is used for testing a piece of software in the machine, whether the software is working fine or not. Now we have private address. So for private address, we have 4 addresses which are called private addresses. These are 10.0.0.0/8. That means prefix size is 8. Then 172.16.00, 12, and 192.168.00/16, and 169.254.00.0.0/16. So this is what is called private address. Generally, it is for a specific host to which this private address can be used. Now multicast address means, now broadcast address is 255.255.255.255/32. It reaches all the hosts connected to the network. You got the idea? Multicast address is connected, the packets of whichever are having this, a specific set of hosts that are connected to the network. This particular packet will be delivered. Not every packet, not every host. So only a few specific hosts will be receiving this multicast packet, right? So now let us see how exactly, after a block of address are assigned to an organization. That means when the organization is given a set of what I meant to say addresses, the network administration either they can individually, manually, in fact, manually assign the addresses, or the same thing can be done automatically through dynamic host configuration protocol. Now, let me tell you, this DHCP is very important topic, and many of the times this DHCP has been asked as one full question like of 10 marks, right? So this you should understand what is DHCP. So basically, DHCP is used. Now here the scenario is, ISP provides a set of addresses to an organization. Now the network administrator who is there in that organization can manually assign addresses to individual connection or individual host, or the routers, whatever are there with the available with the organization. Or the same thing can be done automatically through dynamic host configuration protocol. Now, what is this DHCP? Basically, DHCP is an application layer protocol program, right? So it works in client server, paradigm, and basically it also helps TCP/IP in the network layer. And it's a kind of plug and play, what I would say protocol. Plug and play protocol means can be used in many situations, right? So in first method, what I meant to say, network manager can configure DHCP to assign permanent IP address to hosts and router. This can be done. So there are two types of, DHCP, will do the addressing. One is network manager can configure DHCP to assign permanent IP address to each host. You got the idea? In the routers. Can also be, DHCP can also be configured to provide temporary on-demand IP address. Now, both are possible, I mean to say here. So, second, it has the capability to provide temporary IP address to a traveler. Suppose a traveler comes to a hotel and he wants to use what I meant to say Wi-Fi or any internet connectivity. So, a temporary IP address can be provided to such a traveler, right? That can also be done through DHCP. That can also be done through DHCP. So DHCP can be used both way to assign permanent addresses to the what I am say hosts and router, or it can also be used for assigning temporary addresses, IP addresses to hosts. Now this is how the DHCP packet looks, right? So it has what I meant to say. This size is each size of each field is 32 bytes. 32 bytes means here 8 bytes is for opcode, 8 bytes for H type, and 8 bytes for H length and H count, and transaction ID is full 32 bytes, and time elapsed is 16 bytes, and flags is 16 bytes. So this is DHCP message format. So the message will go in this particular format, DHCP message. You got the idea? Then I have a client IP address, your IP address, server IP address, gateway IP address, and client hardware address, server name, boot file name, options. Now here we will, study all these things. So whenever DHCP is asked, whatever I had explained in the first page, you have to explain that. After that, you have to draw this packet and give all the field explanations. Along with the last field, the options will require more explanation that we will do shortly. So opcode is nothing but it's a operation code. So if this value 8-byte value is equal to 1, it is called DHCP request. You got the idea? If opcode value is equal to 2, this 8-byte contains the value 2, then it is a reply from a host. Now H type is nothing but hardware type. You got the idea? So hardware type means say it is Ethernet or network interface card, and all these things are called hardware type. Hardware length means what is the hardware address. So every MAC address means it is address associated with network interface card, which is 48 6 bytes in length, which is 48 bits or 6 bytes in length. Then H count. Basically, H count is nothing but maximum number of hops that this DHCP packet is allowed to remain in the network. Suppose between source and destination, in between there are 7 stations, 7 routers. So how many hops will be there between the source and destination? I am saying that source and destination, between source and destination, I have 7 routers. So this is my source and this is my destination. I have 7 routers in between. You got the idea? So 3, then this is 4, 5, 6, 7. Total this, I mean to say all of that, they are in between, so these routers are in between the source and destination. So how many hops are there? It is nothing but from source to 1, it is 1 hop, from 1 to 2, second hop, 2 to 3, third hop, 3 to 4, fourth hop, and 4 to 5, fifth hop, and this is 5 to 6, sixth hop, and 6 to 7, seventh hop, and eighth hop. So this is what. So from starting from source to reach the destination, I have covered the entire thing in how many hops? How many hops I have taken to cover this? 8 hops. If 7 intermediate hosts are there, I have taken 8 hops. So here H count will be 8. H count will be 8. And the moment the packet arrives over here to the intermediate host or the router will decrease this H count by 1. So it is allowed to take maximum of how many hops? Only 8 hops. That is called, hop count. And transaction ID, generally it is the sending host which will, what I meant to say, set this transaction ID always, right? And this transaction ID is nothing but I am starting a communication, and it's a kind of communication. Transaction ID is nothing but it's a kind of communication ID. So this will be generated by sending host, and the server, after receiving it, will put back this transaction ID, stating that in response to your what I'm say communication, I'm in response to your this. It's a kind of reference number. You initiated the communication using this transaction ID. So in response to your same transaction ID, I am sending the answer. So kind of thing. So this is what I meant to say. Transaction ID is always set by the sending host to the server, and server will put this transaction ID. When server is sending the DHCP packet in reply, as a reply packet, it will copy this same transaction ID from the uh, you know host which has sent the request into the reply part. And then we have something called as time elapsed. Time elapsed is this. It is nothing but number of seconds since the client has started to boot. So this time it will be putting at 9, 10, 10, 9 hours, 10 minutes, 10 seconds, the client started booting. So from that time it will be calculating, and suppose the DHCP request was sent at 9 You got the idea? So here time elapsed is, it will put how much of time has elapsed from booting time. So since DHCP request was, originated at, say 10, 10 and 50, 10, 10, 50. And actually that will be the difference of the timing, boot timing, and at what time this DHCP message is being sent is called time elapsed. Now we have certain flags. Basically, this flag can have what I am going to say only two values, either 0 or 1. And remaining all 16, I'm sorry, this is 4 bytes, not 32 bytes. It is 4 bytes. This is bits. So this is nothing but a flag. So only one bit out of these 16 bits are used. That one bit can be either 0, which is unicast message to, message to a specific system, or a multicast message to multiple systems. And remaining 15 bits of this are not used. Now client IP address is again for what I am going to say bytes address. It is set to 0 if client does not know its own address. Client does not know its own address. Then your IP address, if client does not know its own IP address, in that case it sends the address, its own address as 000. We'll see in the diagram next. 000. When this message goes to the server, server will assign, DHCP server will assign your IP address. That means you do not know your IP address, so I am assigning this IP address to you. And henceforth, for all communication, that host, after knowing its IP address, will use this as its IP address in next communication. Now, server will again send its own IP, DHCP. Here, server means DHCP server. I am talking of DHCP server. Now, this is gateway IP address. It is nothing but address of the default router. That means here for the sender, default router is 1. First, it gets connected to router number 1. So that's the default, what I'm going to say, router. So this is nothing but gateway IP address is address of the default router. Now server name. Generally, server name is 64-byte domain name of the server. 64-byte domain name of the server. Generally, it is now like you will have www.cambridge.edu.in kind of thing. So that is what I am going to say, domain name. Now boot file name. It is nothing but 128-byte file holding extra information that will be there. And you have options, which is again 64-byte what I would say field with a dual purpose.